Redox reactions are reactions which involve both oxidation and reduction. If you have got sodium, this is a metal. In this state, there's what is called oxidation number. Oxidation number is simply the charge that element has. So for a pure element, the oxidation number is 0. Now, you know that sodium, for it to be stable, it needs to lose an electron, so it forms a positive charge. And it has lost one electron. So it is coming from having an oxidation number of 0 to an oxidation number of positive 1, like this. So when the oxidation number is becoming more positive, that is called oxidation. Okay, so what is oxidation? Oxidation is loss of electrons. So you can see that an electron is lost, and when something loses an electron, it becomes more positive. So that is what we call as oxidation. Now if you look at chlorine, for it to be stable, it needs to gain one electron, right? And then because it has gained an electron, it becomes negatively charged. From where it has an oxidation number of 0. Okay, so you've seen that the oxidation number has moved from 0 to negative 1. So it has become more negative, and that is reduction. So what is reduction? Reduction is gain of electrons, and something becomes more negative. So if you have got, let's say something was having a charge, let me give an example. Something this, let's say this is an element X. It has got a charge of negative 1 here, right? And then if you go on the product, it has got a charge of positive 1. So here you can find how many electrons have been lost or gained. So to find how many electrons have been lost or gained, you look on the product, you have got one positive charge. Okay? Minus, you always say product minus reactant. Minus, on the reactant you have got one negative charge. So positive 1 minus negative 1, that is going to give you positive 2. That means that here 2 electrons have been transferred. Now because it is coming from being negative to being more positive, it is becoming more positive. So that means that this reaction here is oxidation, because every time there is an increase in oxidation number, that is oxidation. And what do we mean by increase in oxidation number? It is simply becoming more positive. Then that is oxidation. Okay, is that okay? Is that okay? Yes. Oh, I can see because it's not recording what I'm writing. The network is a bit of stopping. Okay, so when there is an increase of oxidation number, whenever something becomes more positive, just know that there is oxidation. Now let's say you have got an element Y, it has an oxidation number of positive 2, and then it goes into having negative 1 oxidation number. So you want to see how many electrons have been transferred. Is this oxidation or reduction? So this, you are going to say number of electrons on the product, you have got negative 1, minus, you come on the reactant, you have got positive 2. Now negative 1 minus 2, that is going to give you negative 3, meaning that 3 electrons have been transferred. Now because we are moving from being positive to being negative, okay, something is becoming more negative. So that is called reduction. Reduction is becoming more negative. So this is a reduction process. Is that okay? Okay. Now, a redox reaction is supposed to involve both oxidation and reduction. Let's say, for example, you have got, what can I give as an example? You have got, let's say, hydrochloric acid, which is reacting with uh, What can I even give? Okay, let me say it's reacting with fluorine, and then it becomes hydrogen fluoride plus chlorine. If you look at this compound, when you have got a single element like that, the oxidation number is 0. Even here, chlorine is just alone, meaning the oxidation number is also 0. Now, the oxidation number for hydrogen is always positive 1. When you add the oxidation numbers in a compound, it should give you 0, meaning that the oxidation number for chlorine is going to be negative 1. And then here also, the oxidation number for hydrogen is positive 1. For chlorine is negative 1. Okay, so if you see hydrogen, the oxidation number is constant, meaning that hydrogen, you are not going to show any arrow. Okay, now for chlorine, the oxidation number was negative 1, it is now 0. So I've seen that it is become less negative. It is moving from negative numbers to 0 towards positive numbers, meaning that it is increasing oxidation number. So this is the oxidation. Okay, why? Because there is an increase in oxidation number. Negative 1 is smaller than 0, there is an increase. If you look at fluorine, it has moved from 0 to negative 1. So we are becoming more negative. This is a reduction in oxidation number. Every time you have got a reduction in oxidation number, this is reduction. Okay, so that is such a reaction is what is referred to as a redox reaction. Are we good? Okay. Okay, so I gave an example of, let's say it's the one, an example like this. So I are saying to find the oxidation number, which is just the electrons, you say oxidation number of the product minus the oxidation number of the reactant. On the product you have got a negative 1, minus on the reactant you have got a positive 2. Negative 1 minus 2 is a negative 3. Is that okay? All right. Now, let's understand how do you get to calculate oxidation numbers. Since oxidation numbers are going to be very, very important as we get to discuss redox reactions. So to calculate oxidation numbers, let's say you have got a compound, aluminium oxide. Aluminium oxide is like this. And they have underlined aluminium. They say find the oxidation number for aluminium. Now, you need to know some rules. The oxidation number of an element is just the the oxidation number of an element is just the charge that that element has, or the valence of that element. So the oxidation number for oxygen is negative 2, except in special cases like in a peroxide. When you see this H2O2, this is called the peroxide. So oxygen will not have an oxidation number of negative 2. That's an exception. The oxidation number of hydrogen is also positive 1, except when hydrogen, instead of it reacting with a non-metal, it reacts, let's say, with a metal. It will end up having a negative oxidation number, negative 1. So that's a special case. Alright? The oxidation number of pure element is 0. For example, or not just a pure element, but also a molecule or an atom. The oxidation number is always 0. For example, the oxidation number for aluminium is 0. If you look at molecules like oxygen, the oxidation number is 0. Hydrogen, oxidation number is 0. You also have pure molecules which don't have a charge, like water. Now for this one, the total oxidation number is 0. Total oxidation number is 0. Meaning that if you add the oxidation number of hydrogen and oxygen, you're supposed to get 0. Molecules like ammonia, the oxidation number, the total or the sum should give you 0. Now for charged compounds, the oxidation number should be equal to the charge. For example, a sulfate. If you add the oxidation number of sulfur plus oxidation number for oxygen, you should get the charge of negative 2 because that is the charge of the sulfate. Alright? And then also hydroxide. When you add the oxidation number for oxygen and hydrogen, you should get negative 1. If you look at ammonium, okay, so the oxidation number for nitrogen and the oxidation number for hydrogen, it should give you a positive 1. So these are the rules you need to know. Is it okay? Okay. Now, let's calculate the oxidation number for aluminium in this compound. Now you can see we have got two aluminiums and this compound doesn't have any charge. So we're going to say 2 multiplied by aluminium and then plus 3. Let me put aluminium like this because we are going to be putting there the oxidation number for aluminium. And then plus we have got 3 oxygens, okay? So if you get 2 multiplied by the oxidation number for aluminium plus 3, the oxidation number for oxygen should give you 0 because this one doesn't have any charge. So this is going to be 2. We don't know the oxidation number for aluminium, right? And then plus 3. The oxidation number for oxygen is what? What do you say? Negative 2. This should give you 0. So 3 times negative 2 will give you negative 6. And then you take it and negative 6 to the other side. So we're going to find this will give you positive 6. Divide both sides by 2. And then the oxidation number for aluminium is going to be positive 3 in this compound. That's the oxidation number for aluminium in aluminium oxide. Let's say we have got ammonium ion. You want to find the oxidation number for nitrogen in this compound. So we're going to say the oxidation number for nitrogen, since it's just 1 plus, you have got 4 hydrogens, right? Should be equal to the total, which is positive 1. So this is going to be nitrogen plus 4. The oxidation number for hydrogen is positive 1 because this is reacting with what? With a non-metal. And this should give us a positive 1. So this will give us nitrogen. If you say 4 times positive 1 is positive 4. If you take it to the other side, it becomes negative 4. So the oxidation number for nitrogen in this compound is going to be 1 minus 4, that is negative 3. You always need to include the sign. So that is it. We are good? Are we? Okay. So let's say we have got this compound. Okay, sulfite. You want to calculate the oxidation number for sulfur. So simply say oxidation number for sulfur plus you have got the 3 oxygens, but each oxygen the oxidation number is a negative 2. It should give you the total oxidation number, which is the power there, which is a negative 2. So this will be the oxidation number for sulfur is going to be 3 times negative 2 will be negative 6. You take the 6 to the other side, that becomes positive 6 and then minus 2. And that the oxidation number for sulfur is going to be positive 4 in this compound. That is how you work it out. Okay. What other example can I give? Let's say we are talking about this compound. Okay, this is the compound that we have. And the question is find the oxidation number for sulfur. Now if you look at this compound itself is not charged, right? You don't have any charge there. So just say 2 multiplied by aluminium, the oxidation number for aluminium, and then plus, how many sulfur atoms do you have in this compound?
3.
Yes, 3, the oxidation number for sulfur. And then how many oxygens do we have?
12.
Yes, 3 times 4, that is a 12. The oxidation number for oxygen, this is supposed to give us 0. So we know that aluminium is in group 3, so the oxidation number is going to be positive 3, and then plus 3 oxidation number for sulfur.
Sir, why would you put zero there?
This is oxygen, it's not 0.
Oh.
Yes. Plus 12. The oxidation number for oxygen is a negative 2. It's supposed to give us 0. So this is going to give us positive 6 plus 3 multiplied by the oxidation number for sulfur. And then 12 times negative 2, that's negative 24. That is going to be equal to 0. If I take 24, the other side becomes positive 24. I take 6, it becomes negative 6. So this will be 3 oxidation number for sulfur. That is going to be equal to 24 minus 6. That is a positive 18. And then divide both sides by 3. So the oxidation number for sulfur then is going to be positive 6 in this compound. Is that okay?
Sir, the oxidation number for aluminum is positive 2.
Yes, it's positive 3. Just pick the group number where aluminium is.